Hello everyone, I am Priyadarshan Sadhu from Mechanical 3rd year. Today I'll briefly explain how heat is transferred to an aluminium plate by solar radiation. We'll take the help of a simple problem for our understanding. These are the different parts of this presentation. Before we jump into the problem, let's know what solar radiation actually is. So this solar radiation is caused by numerous nuclear fission which occur in the sun. These electromagnetic waves have a very high temperature of about 5800 Kelvin and has the same spectrum that of a black hole. The problem we'll see in the upcoming slides has a special coating which absorbs this radiation and helps the aluminium plate to heat up faster. So now we'll look into the objectives of heat transfer analysis. There are numerous objectives as to why we perform heat transfer analysis. Some of the basic ones have been listed over here. One of the most important reason is to model the basic heat transfer process and identify the modes by which the heat is being transferred. It may be convection, it may be conduction, or it may be, in this case, radiation. We can also use the energy balance equation to determine the temperature and flux. We can design fins and calculate its performance. We can try to recognize basic convective heat transfer and apply appropriate methods for quantifying convection. We can calculate convective heat transfer coefficient for internal and external flow. We can design heat exchangers. We can try to predict their performance, and we can also determine how radiation heat transfer actually works. So this is our problem statement, and we'll quickly jump into the schematics to give you a better understanding of the problem. So the broken lines denote that the plate is much longer, and because there is no particular size given in the problem, we have taken such an approach. The width is given as 4 mm. The special coating has an absorptivity of 80%, that is 0.8, and emissivity of 0.25. The incident flux is 900 watt per meter square. E is the energy lost in this entire interaction of radiation with the aluminium plate. Q convection denotes the heat loss due to convection. Temperature of the air which is incident is 20 degree, and the convective heat transfer coefficient is 20 watt per meter square Kelvin. The aluminium plate has a specific heat of 900 joule per kg Kelvin and density of 2700 kg per meter cube. The initial temperature of the plate is 25 degrees centigrade. Now we'll quickly look at the assumptions that we have to take in order to solve the problem. Negligible end effects, uniform plate temperature at any instant, that is the temperature of the plate should be constant throughout the plate at any instant. The properties, of course, should be constant. The bottom surface should be adiabatic. Negligible radiation from the surroundings, as that can also affect the analysis that we are doing. And also there should be no internal heat generation. Now we'll jump into the analysis, and for the part A, we would apply the energy balance equation at an instant of time to a control volume about the plate, which is E in minus E dot out equal to E dot state. It follows for a unit surface area. We can use this formula only if we consider a unit surface area. So the formula turns out to be like this, and after rearranging and substituting, we obtain change in temperature with time, which is equal to this. After putting all the values, we get the change in temperature with respect to time is 0.052 degrees centigrade per second. Now moving on to the next question. Here the question states that we'll have to consider that the state is steady, that is EST is equal to 0. Then the energy balance equation reduces to this, and if we put the values, we get the T, the unknown temperature T, as 321.4 Kelvin, which is equal to 48.4 degrees centigrade. And for the last part, we would use this particular formula, and we would determine the various points for absorptivity and emissivity according to the temperature. And the graph that we get is as follows. In the graph we can see that the temperature is plotted along the y-axis and the emissivity is plotted along the x-axis. We have the straight black line, that is this line, is represents the absorptivity when it's 1. The next line, the one with x, has the absorptivity 0.8, and the last one with this circular part shows the curve when the absorptivity is 0.5. Now we come to the comments which we arrive at after solving the problem. The surface radiative properties have a very significant effect on the plate temperature, which actually decreases with increasing emissivity and decreasing absorptivity. And if a low temperature is desired, the plate coating should be characterized by a large value, in fact a very large value of epsilon by alpha s. The temperature also decreases with increasing H being the convective heat transfer coefficient. And with this we come to the end. Thank you very much.